Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2016 Specialist Maths Exam 1. And yeah, so let's smash through this paper. Like always guys, before I start this video, if you guys want private tutoring in Specialist Methods, Physics or Chemistry, you can always email me through this email. And yeah, let's smash through this paper. So right now, I'm actually going to take my time going through the questions because I want to explain the concepts to you guys. Those who have not, done Specialist, maybe if you don't understand some concepts, I'll try to explain it, as simple as I can. And yeah, let's do this paper. So question 1, a taut rope of length this is just 1 plus 2 over 3, which is 513. Pretty much this over here is 513 meters. This over here is 513 meters. So a taut rope of length this suspends a mass of 20 kilograms from a fixed point O. As we can see, a horizontal force of P newtons displaces the mass by 1 meter horizontally. So from here to here, this distance here is pretty much 1 meter. And we know that the length of the rope from here to here is 513 meters. So let's write that nice. So 513 meters. Alright, so the taut rope is then at an angle of theta to the vertical, as we can see. Show all forces acting on the mass on the diagram. So, okay, all forces. That's not too bad. So, if you have a mass, anything that has mass has to have gravity acting on it, or a gravitational force. So, for this example over here, this mass over here, the center of mass will have pretty much a gravitational force, so always a downwards gravitational force, as you can see. And this is going to be 20g, where 20 is the mass and g is 9.8. It's the gravitational acceleration. We also have an actual tension force that's going to be acting on the rope from here to here. And it's going to be upwards a tension force. And let's write that down. That's going to be a tension force. All right, and force P is also shown, so that's good. Let me just kind of run it like that. All right, perfect. So, yeah, those are the only forces we have, 20g and a tension force. Okay, show that the sine theta is 3 over 5. Okay, so sine theta. So this is our theta, and we know our opposites over here, and our hypotenuse is over here, because it's a right angle triangle. So we know that, okay, sine theta is what? It is opposite over hypotenuse. What's our opposite here? It's that 1 meter over your hypotenuse, which is 513. So let's write that down. 513. Hence, it's 3 over 5. That's the ratio. Perfect. We've shown that. Find the magnitude of the tension force in the rope in newtons. Okay, we want this tension force. We want to calculate that T value. So what I'm just going to do is, if I can just take this over here, only the force part. If I can just copy and pretty much place one right over here. Perfect. Like that. Let's have a look at this. Let me just rub this, and we only need this part. Okay. So this is our tension force acting here, and this is your P. Now, what I'm going to do is I'm going to do a vector resolute. So I'm going to say that in the direction, the horizontal direction, I'm going to put that as I, and the vertical direction is J. So what I want to do is the best thing, to do this question is to look at the vector resolute in the vertical direction, because we know that the ones that are, vertical is the 20g, this one over here, because it's vertical. We also know that there's going to be, if we, the T here, we can, break it down to its components, for example, like this, which will, these are your vector components. So these two vectors make up the value of T. So, and we just want the, in the direction of J, where J is the vertical. So in the direction of J, we know that this one here is just going to be, we know this is theta. So this one's going to be T cos theta. This part over here, so yeah. And we can see that it's an upwards force, and whereas this one's a downwards force. Remember, the formula, if we want to find the tension, you should know that the formula, force, the net force pretty much, is equal to your mass times your acceleration. So what's the net force? It's the addition of all forces in the vertical direction. So, okay, well, it's t cos theta, which is positive because the arrow is up. So let's write that down. So it'll be t cos theta. And also this one here, but it's going to be minus 20g because it's a downwards, it goes downwards. Minus 20g. It's equal to your mass, which is 20 kilograms, times your acceleration. Well, here, remember, there is, the acceleration 0. It's actually not even moving. It's still, by the way. Yeah, so in the vertical direction, it's not going to be moving. They're moving it with p, a force of p. So it will have an acceleration in the horizontal direction, but not in the vertical. So we can just let the acceleration actually be 0. So your acceleration would just be 0. All right. So that will just be, t cos theta is equal to 20g, where t is 20g over cos theta. So we just need to find cos theta. Now, luckily, what we have just done is, okay, we found this ratio over here, which is, sine theta is this. So if I can just draw a right angle triangle, have a look at this. So if I draw a right angle triangle, let's say this is theta. This one here is your opposite, and this is your hypotenuse for sine. Yes. So this would be 3, and this one here would be 5. Just because this is a perfect right angle triangle, I already know this one's 4. You can easily do that by Pythagoras theorem. So yeah, if I want cos, we know that cos is adjacent over hypotenuse, which is 4 over 5. So it will be 4 over 5. So it's just going to be 20g 4 over 5. Which is 20g times 5 over 4, which, you can cancel those out by 5. So hence your final answer is 25g newtons. Pretty much, yeah. That's how you would do that question. Perfect. All right, let's move on to the next question. Question 2. A farmer grows peaches, which are sold at a local market. The mass in grams of peaches produced in this farm is known to be normally distributed with a variance of 16. So we know that the standard deviation is going to be 4. A bag of 25 peaches is found to have a total mass of 2,625 grams. Based on this sample of 25 peaches, calculate an approximate 95 confidence interval for the mean mass of all peaches produced on this farm. Use an integer multiple of the standard deviation in your calculations. Okay, that's not too bad. So we know that for a 95% confidence, what's the formula? We know it's going to be your sample mean minus your z value. Well, here it's 2. To the nearest integer is just 2 for 95%. So 2 times your s value, which is your standard deviation, over square root of n, comma, x plus 2 s square root of n. This is the formula that we're going to use. So what's your sample mean? Okay, we want a sample. So what do we know? We know that there's 25 peaches, and the total mass of those 25 peaches is 2,625. So if I was taking a sample, let's say 1, I just want to just take 1 by hand. What is the mass? What's that? That's your sample mean. So it's just going to be 2,625 divided by 25, which is what? So I'm just going to say 2,625, 25, 1, 1, 2, so that'll be 0, 5, 5. So 105 pretty much. 105 grams. All right. Your S value, which is your standard deviation, we already know that. That's 4 from this one over here. So in specialist, you kind of have, your standard deviation is written as S. So yeah, don't get too confused with that. And your N here is going to be 25 because we have 25 peaches. So we have all those values. Now let's put them in the formula. So it's going to be 105 minus 2 S, which is 4, square root of 25, which is just 5. 105 plus 2, 4 over 5. And let's do that. So this is just 105 minus 8 over 5. 1 over 5 plus 8 over 5. So that will be what? So what's 105 times 5? 5 times, 25 here. 0 to 5. So 525. So it'll be, what's 525 minus 8? So that'll be 517, if I'm not mistaken. Yeah. Yeah, so this will be 517 over 5 here. And what's 525 plus 8? That's going to be 5, is that right? If I do that, yes. 533 over 5. Perfect. That is your 95% confidence interval. Done. Nice and basic question. Question 3. Find the equation of the line perpendicular. So we want the line that is normal to the graph of cos y plus y sine x, this. Okay. Because we have, in terms of x and y, we're going to use here implicit differentiation. So how do you even use implicit differentiation? What I would do is, for every part here, I'm going to pretty much find the derivative with the respect of x. For example, I'm going to write d dx for this part over here, which is cos y, plus d dx y sine of x and d dx of x squared. Okay, we have this. So, okay, let's have a look at this here, this first part. Let's break this down and explain how to do this. So, okay, cos y. Now, I want to show you what you can easily, do this. If you're kind of, how to use implicit differentiation, you can easily do this in a second. But I just want to show you how, let's just use the chain rule to do this one over here. So let's let u equal y. So, which means that y is actually equal to cos over u. So u dash is 1, isn't it? But because remember, it was in terms of y. For example, u equals y. So u dash is 1, yeah? The derivative of y is just 1, because, yeah. And we have to multiply by dy dx because we had it in terms of y. If it's in terms of y, like for the example, this one, and you derive it, you have to multiply by dy dx. So we would write dy dx. So y dash is negative sine u. Now we just need to multiply these together, so it'll be negative dy dx sine of x. Well, sine of u, which u is y. Perfect. We've just found the derivative of this part over here. Yeah, so let's just rub this part off. We don't need that anymore. And let's put that right on here. Now let's find the derivative of this next part, which is this over here. Now there's two things that are being multiplied, so we're going to use the product rule here. So I'm going to let u will equal y and let v equal sine of x. U dash, again, do the same thing. So what's the derivative of y? It's just 1. And multiply by dy dx because it's in terms of y. And v dash is just cos of x. By product rule, it's just cross multiplying these ones and adding them together. So it will be y cos of x plus dy dx. Yep, so y equals cos of x, dy dx sine x. Done. So that is your deriving that one over there. And yeah, let's put that there. I'm going to put that right over here, and I'm going to add, because it's been added, I'm going to put a plus here. And the last one, it's very easy. In terms of x, it's just 2x. Perfect. We have an expression, a nice very expression here. So what I'm going to do is I'm going to try to solve for dy dx. So what I'm going to do is I'm going to bring dy dx on one side. So I'm going to say dy dx is, sine of x minus sine of y is equal to 2x minus y cos of x. Perfect. So therefore your dy dx is just 2x minus y cos of x all over sine of x minus sine of y. All right. Okay, what we want to do is, luckily we have a point and we want to find the gradient that is perpendicular. So what I'm going to do is I'm going to sub these two values in over here. So dy dx, given that we're subbing 0 and negative pi on 2, so 0, negative pi on 2 is going to give us, so what's 2 times 0 is just 0, plus pi on 2 here. What's cos of pi on 2? So cos of pi on 2 is, let's actually, wait, sorry, what am I doing? Oh my god. Wait, so that's that, so negative plus pi. What's cos of 0? Sorry, what's cos of 0? It's just 1. So cos of 0 is 1 divided by, what's sine of 0? Sine of 0 is just 0. And what's negative sine of negative pi on 2? You know, that can just be, so what's sine pi of 2? So sine pi of 2 is just 1. So your final answer is pi on 2. This here is your gradient. But we want the gradient that is perpendicular. So the perpendicular gradient, we know it's negative 1 over that gradient, which is pi on 2, which gives us negative 2 over pi. Now we have the gradient and we have the point, so we can just use y minus y1 equals mx minus x1. So y is equal to negative pi on 2. Your gradient, which is negative 2 over pi, x. And, you know, x minus 0 is just 0. So, yeah. Which is therefore, hence your final answer is going to be negative 2 over pi x minus pi on 2. Yeah. Perfect. That is your equation of the line that's perpendicular. That's not too bad. Question 4. It says chemicals are added to a container so that a particular crystal will grow in the shape of a cube. The side length of the crystal, x millimeters, t days after the chemicals were added to the container is given by this. Find the rate at which the surface area, in terms of square meters, of the crystal is growing 1 day after the chemicals were added. Give you an answer in terms of square millimeters per day. Okay, so it's a lot of things, you know, when you're reading this, it's a lot, but just think of it simply. So we have a cube. Let's just draw a nice cube, actually. A very basic cube. Let's just draw a cube here. All right. This is what we have. We have a nice cube. It's not the best cube, but it does the job. Let me kind of nicely draw that there. And this one over here. So we have this cube. And we know that the length of this side here, because it's a cube, so the length is x, which is this one over here, given by this. And what we want to do is we want to find the rate in terms of surface area. So we want to find the formula for area. So the surface area, actually. So what's the actual area? Let's just think about it. What's the area of one surface over here? It's just going to be x squared, isn't it? But remember, there are 4 sides. We want the surface area. So there is 6 sides, 6 sides in a cube. So we're going to multiply that by 6x squared. This is our formula right here. This gives you your surface area. Perfect. So if I now know this, and I know that x is just, arctan of t, so your area is 6. We can call it just tangent inverse of t squared. Perfect. And we just want to find the rate at which the surface area, so rate, so dA dt, the surface area of the crystal is going 1 day, so when at t is equal to 1. So let's do that. So we just want to find dA dt. So what's going to do? We're going to keep that 6, that constant. We're going to multiply that 2 out. We're going to find the derivative of the inside, which is just 1 over 1 plus t squared. And we're going to multiply it by the tan of t minus 1 from the power, which is just 1. Simplifying this further, so dA dt is going to be 12 tan inverse of t all over 1 plus t squared. All right, we got the beautiful formula for the rate. Now what we just need to find is when t equals 1. So what is your dA dt given that t is equal to 1? Let's do that. So it's going to be 12. So when tan, the inverse of tan is equal to 1, it's just pi on 4. All over, 1 plus 1 squared, which is just 2. Which we're saying is, 6 times pi over 4. That's what we're just calculating. So let me just move this all to the side. Right over here. That's going to be pretty much, the final answer is 3 pi on 2. Yes, so yep, 3 pi on 2 millimeter squared. Done. That's your final answer for that one. Question 5 states that consider the vectors A and B and C, where D is a real constant. Find the vector resolute of A in the direction of B. So what we want to do is, so this is vector A right here. This is your vector A, and this is your vector B. And we just want to find if I just draw it like this, okay, we just want to find this vector over here. This is our vector resolute. We want to find this vector right over there. So to do that, you should know the formulas for vectors. For a vector resolute, it's just going to be A multiplied by the B. So your dot product over, because it's in the direction of B, so it's going to be B squared multiplied by B. So, okay, what's A dot B? So let's do that. So I'm just going to move everything on the side. Let me just move everything on the side here. Keep everything basic. There we go. So what's A dot B? A dot B is going to be 3 times 1. 3 times 1 plus, just rub that out. Again, so 5 times negative 2, so it will be negative 10, pretty much. And negative 2 times 3. All right, so that's going to be 3, negative 10, negative 6, which is just negative 16, plus 3, which is your final answer is negative 13. And perfect, so that is that. I'm just going to rub this off over here. I'm just going to keep that on top. So that's your A dot B. So A dot B. So what about B? The magnitude of B, it's just going to be the square root of, 1 squared, 2 squared, which is 4, plus 9, which is 3 squared. So that will be root 14. But remember, we're squaring it, so it'll just be 14. Just take and put a square there. Yeah. So hence your final answer is negative 13 over 4 multiplied by the vector B, which, negative 14 multiplied by vector B, which is just I minus 2j plus 3k. That is your vector resolute perfectly. And that's done. Yeah, that's not nice. Just let me, wow. All right, that's it. Next question. Find the value of D if the vectors are linearly dependent. So this is such a common question in exams. A very fast way that I normally do it, but I'm going to take my time doing it, is to use this. It's called matrices. So what I'm going to do is, okay. What I'm going to do is I'm going to multiply a variable called alpha to A, the vector A. Plus, I'm going to multiply a vector, constant B, beta, to the vector B. And I want to equate that to, C, vector C, which we have. So, okay, alpha, we can actually write these vectors, for example. You know how, your A vector, this A vector over here, is written as this. We can write it as a matrices. So, we write 3, and then this one here's 5, and this one's -2. And we close it. So we can write it as a matrices. So it'll make our life easier if we just use matrix notation here. So, for example, we know that A is 3, 5, -2, and we close that, plus your beta, which is 1, -2, 3, and that should all equal to the matrices of C, which is just 1, 0, D. All right, now we got this beautiful equation. What we can do is we can start expanding. For example, we're going to expand this first part. So alpha times 3 plus beta times 1, and then it should all equal to 1. So it'll be 3 alpha plus beta equals to 1. That's your first equation. Your second equation is going to be alpha times 5 plus beta times -2 equals all to 0. So it'll be 5 alpha, -2 beta, and that's all going to be 0. So that's your second equation. And your third equation will just be -2 alpha plus 3 beta should all equal to D. And that's your third equation. Now we just need to solve. What I would do is solve 1 and 2. And I'll get alpha and beta and sub it into this equation, the third equation, to get the value of D. So yeah, let's do that. What I can do is I can say that if we multiply this equation here by 2, and add it with the second equation, this one, the B value should be eliminated by elimination. So let's do that. So if I'm saying that it'll be 6 alpha plus 2 beta is actually equal to 2, adding it with 5 alpha minus 2 beta equals 0. So adding these two up, we get 11 alpha is equal to 2. For your alpha value is pretty much 2 over 11. Done. So we've got that. Luckily, we can just use a basic equation like this one and calculate beta. So beta is just going to be 1 minus 3 alpha, which, alpha is 2 over 11. We're saying what's 1 minus 6 over 11? So it's just 11 minus 6. 5 over 11, pretty much. So beta is 5 over 11. And done. So we got our alpha and beta. Now we can sub it into the third equation to find D. So let's do that. So what's -2 alpha, which is 2 over 11, plus 3 beta, which is 5 over 11, should all equal to D. That'll be -4 over 11. So plus 15 over 11. Adding these two up, we get 11 over 11, which is equal to 1. So your D value is actually just 1. Perfect. That's it. And you can do that quickly in an exam. I just want to kind of explain how to use this kind of notation. Yeah, you can do that. Okay, question 6, complex numbers. So write this in the form of A plus B. So we want to, okay. So let's do this. So let's look at the top part here. Let's, change it in terms of sys form because we're dealing with high powers here. So what I'm going to do is I'm going to just change it into its polar form. So 1 minus root 3i. What is it in terms of polar form? Okay, well, we need to find the magnitude of it. So the square root of, the 1 squared plus the square root of root 3 squared, which is what? It's all equal to 2. So it's going to be 2 cis. And what's the angle? To find the angle, imagine just drawing a Cartesian plane here and saying, okay, 1, so this here is your real axis, and this here is your imaginary axis. And we're saying 1 negative root 2. So your angle is going to be right over here. This is your angle, and that's the angle that we want to find. What is it? Well, it's very easy. Isn't it just going to be the tan inverse of, root 3 over 1? That's the formula, yeah. Root 3 over 1, which is, in this case, it's just pi on 3. But it's going to be negative pi on 3. Be careful. Remember, it's this angle that at the bottom, it's below the real axis. Yep. Again, to find the, polar angle, the angle is very easy. It's just, your tan inverse of this one divided by this one. Yeah. We get that. Done. And let's convert this one too here. 1 plus root 3. Again, you know, finding the magnitude is going to be the same, 2 cis. And what about the angle? Well, the angle is just going to be in this quadrant over here, which is what? Again, you know, what's tan root 3 over 1, which is just pi on 3, but it's going to be the positive pi on 3. Done. Perfect. We got these beautiful polar forms. So by using the Moir's theorem, let's write them. So it's going to be 2 cis negative pi on 3 to the power 4, all divided by, oops, that's not a nice one, 2 cis pi on 3. So by the Moir's theorem, for the value of a 2, we actually, you know, multiply the power of 4. So what's 2 to the power of 4? So it's going to be 2 to the power of cis. Cis is going to be the same, but for the angle, it's just going to be multiplied by 4. So it'll be negative 4 pi on 3. That's the Moir's theorem. All divided by 2 cis pi on 3. Now, luckily, we can cross that out, and that's going to be to the power of 3, you know. So let's write that down. So that's just going to be 8. And, okay, when two polar forms are being divided by each other, the angles just minus each other. So, for example, this angle minus this angle. So, for example, we have 8, therefore cis. What's negative 4 pi on 3 minus pi on 3? That's hence 8 cis negative 5 pi on 3. Now, okay, this angle is not between the values of theta that we want. Remember, in complex numbers, we want the angle to be between, if I'm not mistaken, it's going to be between pi and negative pi, where it's not including negative pi. So yeah, if we want that, we just need to add 2 pi into it. So what's so it's going to be written as 8 cis. What's negative, 5 pi on 3 plus 2 pi? That's then 8 cis. So that's negative 5 pi plus 6 pi. That's pi on 3 pretty much. Yeah, and we are done. So this is the polar form, but we want to get it in, Cartesian form. So easy. So it's going to be, 8. Now cis is just cos pi on 3 plus I sine pi on 3. So cos, pi on 3 is half. And sine pi on 3 is root 3 over 2i. Hence, your final answer would be 4 plus 4 root 3i. That's your final answer. Perfect. Next question, question 7. Find the arc length of the curve this from x equals 0 to x equals 2. Now, you should know the formula. It's in your actual formula sheet. So, for example, I want to let this, y, I'm going to call it y of x, is equal to 1 over 3 x squared plus 2 power 3 on 2. Now, the formula for arc length, to find the length, is just length is equal to the integral from 0 to 2, the square root of 1 plus, because this is in terms of y, so we're going to write y dash of x squared, if I'm not mistaken. Is that right? Yeah, I think that is, as I'm seeing from a formula sheet, yes, that's right. dx, that's your formula. So let's find y dash of x first. What's y dash of x? Y dash of x is going to be, 1/3, that constant stays outside, multiplied by the power, which is 3 on 2, multiplied by the derivative inside, which is just 2 of x, all, and, put it all back together, so plus 2x, but minus 1 from the 3 on 2, which is 1 over 2. That's going to be pretty much a half. You just cancel out. Again, you're multiplying by 2, so it'll just be actually x. X equals x squared plus 2 half. In other words, x is just the square root of x squared plus 2. That is your y dash of x. Now we're squaring y dash of x. So it will just be x squared plus 2. So I'm just going to expand that. So x to the power 4. Yeah, so x to the power 4 plus 2x squared. Done. And we're also going to add 1 to it, because from this equation, you add 1. So plus 1, that's going to be y dash of x squared plus 1. And we're going to take the square root. Luckily, this equation, if you really have a look at this, isn't this a very similar equation? Like, imagine that let u be equals x squared. Like, let u equal x squared. Isn't it just u squared plus 2u plus 1? And that's just u plus 1 squared. Where u is, in this case, is just x squared. So it's just x squared plus 1 over squared. So x squared plus 1 squared. Yeah, so just having a look at that, you should already know that this just simplifies to x squared plus 1 squared. And then we take the square root of it. Finally, we take the square root of it. So the square root of, x squared plus 1 squared, which is just hence x squared plus 1. So yeah, we just need to find the integral now from 0 to 2 of x squared plus 1. Perfect. And dx. That'll be, x to the power 3 over 3 plus x from 2 to 0. That's hence going to be 2 to the power 3 over 3 plus 2, minus, it's going to be 0. So your final answer is 8 on 3 plus 2, which is 8 plus 6, which is, 14 over 3. That's your length. And we just call it 14 over 3 units. Yeah, hope that's right. Perfect. Let's move on to the next question. Next question is question 8. It says that the position of a body with mass 3 kg from a fixed origin at t times second, at where t is greater than 0, is given by I equals this. So this is your position, where comparisons are in meters. Find the expression for the speed in meters per second. Okay, because this is position, what do we know about position? It's the displacement. Be careful. We want the speed, which is a scalar quantity. So if we kind of derive this expression, we'll get the velocity. So if I was deriving this one over here, which is just, r dot, you can write as r dot, the derivative, which is the speed. In terms of t, it's just going to be, what's the derivative of that, plus what's the derivative of that in terms of its I and j components. So this one over here is just going to be 6 cos of 2t in terms of I. The other one over here, it's going to be plus, I'm not mistaken, yeah, plus 4 cos, sine 2t in terms of its j component. Is that right? And we've done the derivative, which is negative sine. Yes, perfect. So that's your velocity, but we want the speed. So be careful. So what we want is to find the magnitude of this one over here to find the speed. So your speed is just the magnitude of the velocity, which is, the square root. Oh, it's going to be a big square root. So, okay. So it's going to be square root. So it'll be, squaring all this is going to be, 36 cos squared 2t plus 16 sine squared 2t. And if I'm not mistaken, that's all you need. Yeah, just find the expression for the speed in meters per second. Yeah. That should give you 2 marks, pretty much. Yeah. So the next question is, find the expression of the body in meters per second when t is equal to pi over 12. That's easy now. It's just saying, what's r of at pi on 12, which is the square root of, so what's, 36 being multiplied. What's if you pi over 12 times 2 is just pi on 6. What's cos pi on 6, actually? So cos pi on 6 is root 3 over 2. And imagine squaring root 3 over 2. It's just 3 over 4. So it's just being multiplied by 3 on 4 here. plus 16. What's sine of pi on 6? So sine pi on 6 is a half. And imagine squaring it, so it's 1 over 4. So it's going to be 1 over 4. That's pretty much it. And, simplifying this much further, we get, how many, actually 9, 18, 27, 36. So what's 9 times 3? So that's going to be 27 plus 4, which is root 31 meters per second. That's that. Done. Next question. Find the maximum magnitude of the net force acting on the body in newtons. Okay, the net force, so by Newton's second law, the net force is equal to your mass times your acceleration. So acceleration is written as, by the way, it can be written as r dot of t, which is the derivative of the velocity. So let's find r. We'll call r dot of t, which is acceleration, is equal to what? It's just the derivative of this one over here, which is what? It'll be negative 12 sine 2t I plus 8, find the root, just cos of 2t j. Perfect. And so multiplying that all by mass, so what's m of r of t? So the mass is a scalar quantity, which was 3 kilos. So just multiply everything by 3. So what's oh my god, so it'll be negative 36 sine 2t I 8, 16, 24. So it'll be plus 24 cos 2t. Now this here is your actual, this formula here is your net force, and we want to find the magnitude. We want the magnitude of the net force. What we want to do is, okay, we want to find the actual magnitude of it, of the net force. So it will be the square root. It will be the square root of. So wow, it's actually a big equation. So what's 36 squared sine squared 2t? So that's that, plus 24 squared plus, so times cos, cos squared t, 2t. All right, we have this expression now. So find the magnitude, so find the maximum magnitude of the net force. So this is the magnitude of the net force we've just done here. What else can we do? Okay, so we can kind of simplify maybe this. If I just say the square root of, so 36 is just, if I'm honest, it's 4 times 9. 9, 18, 27, 36 squared sine squared 2t plus, and this one here is just 4 times 6, 12, 18, 24, so it's 6 squared cos squared 2t. And I can take that 4 now. It's going to be 4 square root of just 9 squared, which now it's 81 sine squared 2t plus 36 cos squared 2t. And now, okay, so by using the formulas in your formula sheet, what I'm going to do is this cos squared, we know that sine squared of, let's say, for example, here's 2t plus cos squared 2t must equal to 1. So I can just say that I can rewrite this whole thing as 4 square root and just, so 81 sine squared 2t plus 36. So cos squared 2t, I can just rearrange it in terms of this. So it will just be 1 minus sine squared 2t, which is, just 4. 81 sine squared 2t plus 36 minus 36 sine squared 2t, which is, if you simplify it further, 81 minus 36. So, all right, wow. So if I add 44 plus 1, so it'll be actually 45 sine squared 2t plus 36. If I'm not mistaken, that's right. Yes, so if I add 40, that's 70, 80, yes. So, okay, have a look at this. So this is our magnitude of the net force, but we want to find the maximum. So okay, look at the sine squared 2t. Now, you imagine drawing that. So if you're not too sure, just imagine like this. This is y equals sine 2t right now. Imagine this is, so we know that it's going to have a period of pi here. And here is going to be pi on 2. So this here is going to be pi on 4. And imagine, like, if you're worrying about that squared, it's pretty much all the things that are at the bottom are just going to be reflected onto the top. So it will look like, overall, it will look like this. If you do physics, it pretty much looks like when you have a commutator in the AC. So yeah, it looks like this. So if I want to find this point of maximum, this value here, this max value, isn't it just, if I can sub in pi on 4, I should get it? Yeah. That's pretty much it. So imagine that, okay, if I sub in pi on 4 in the equation, when t is equal to pi on 4, I should get the actual maxed value of sine, and yeah, we can use that to our advantage to find the max value. So what's 45? Okay, so if we say it's a sine pi on 4, which is then times by 2, so it's pi on 2, and that's 1, and you're squaring it's just 45 plus 36, pretty much. And that will be for square root, oops. All right, 40, so 4, 5, 6, 7, pretty much 81. Yep, so it's 9 times 4 pretty much. 9, 18, 27, 36. So 36, wow, that was a long. Find the maximum magnitude of the net force, so 36 newtons. Done. I hope everyone understood that. Question 9. Given that cos x minus y is 3 over 5, and tan of x times tan of y equals 2, find cos x plus y. So what I would do is, okay, look at my formula sheet. I'm just going to have a look at the formula sheet. You don't need to memorize these formulas, these circular function properties here. So, okay, what's cos x? If I say cos x minus y, like cos x minus y is just cos of x, cos of y, plus sine of x multiplied by sine of y, and that's overall equal to 3 over 5 from the expression. And what about this one over here? So if you know that, okay, tan of x is just sine over x over cos of x, and then multiply by tan of y, which is again sine of y over cos of y, should equal to 2. Yes, and if I multiply, if I bring these here to this side, it should be pretty much sine of x sine of y is equal to 2 cos of x cos of y. Yes. So we can always see, okay, I can see kind of, okay, cos of x times sine of x is just given an expression. So, okay, what I can do is, okay, let's just say let some variables to make our life easier. So let u is just equal to sine, actually, let's let u actually equal to cos of x multiplied by cos of y. And let v equal, sine of x multiplied by sine of y. So in other words, cos of x, so cos x minus y is just what? It's going to be u plus v Yes, and that's equal to 3 over 5. And this expression here can be written as what? So so it's going to be v is equal to 2u. All right. So I can actually, and we just want to find cos x plus y, which is, so cos x plus y, which is, so cos x plus y is this expression right over here. It's the same as this expression here, but it just has a minus here. Has a minus. So, and yeah, we can just change that to what? We can just say that that's u. Remember, that's u and v, so it's just u minus v. That's what we want to find. What's u minus v? U minus v. That's what we want to find out. Luckily, this is very easy because we know that v is equal to 2u, so I can actually shove that into this function. So that will be, you know, u is equal to plus 2u is equal to 3 over 5. Hence, 3u is equal to 3 over 5. So u, in this case, is what? 1 over 5. So I know u is 1 over 5. That's good. What about v? Well, we know that, you know, v is equal to 2 times u, so it'll be 2 over 5. So hence, what's your u value, which is 1 over 5, minus your v value, which is 2 over 5, which is negative 1 over 5. That is, you know, cos x plus y, pretty much. That's your final answer. Done. And this is the last question. So yeah, question 10. All right, so question 10 states, solve the differential equation this, given that y1 is this, and express y in terms of x. Okay, so this has, you know, in terms of y and x, so just from that, I know I'm going to have to probably use separation of variables. So, okay, what I'm going to do is, I just want dy dx to be equal to the expression. So what I'm going to do is bring this to that side to make my life easier. Dy dx is equal to 1 over 2 minus y times 1 over square root 2 minus x squared. Now, okay, we can actually use separation of variables. If two things are being multiplied and one's in terms of y and one times of x, what I like to do is, this is the kind of formula that I've just memorized in my brain. I normally just say 1 over, so what's the thing in terms of y? It's this, yeah? Imagine, yeah, so bringing it over here, 1 over 2 minus y, and, you know, finding the integral in terms of dy is equal to the integral of just this expression by itself. 1 over square root 2 minus x squared dx. So did you just see that? So if I know that two things are being multiplied, one's in terms of y and one in terms of x, what I'm going to do is I'm going to find the integral of the 1 over this value over here. Yes, in terms of dy, and I want that to be equal to, again, the integral of this one over here, which is just the integral of pretty much 2 minus y dy is equal to this over here. 2 minus x squared dy dx. Now, okay, this is easy because that's just 2y minus y squared over 2 is equal to what? So if you just have a look at your formula sheet, to integrate this, you should know straight away it's like a sine. So we can just integrate that as sine inverse of x over root 2 plus c. Done. We've pretty much done a lot here. So what I want to do is I want to find that initial condition. So to find that, using that initial condition, we know that when x is 1, y is equal to 0. So pretty much this here is part 0. Sine, and that other one's 1. So what's 1 over root 2 is equal to plus c. So c in this case is what? Whatever. So sine, is just c is actually just negative pi and 4 in this case, pretty much. So yeah, sine inverse of 1 over root 2 is just pi and 4, and then yeah. So we have that, and let's write that down. So your actual, okay, let me just take this and decrease it down here. All right, so your final is just 2y minus y squared over 2 equals sine inverse of x over root 2 minus pi on 4. Now we want to get it in terms of y. We want to express it as a y as a function of x. So, all right. Now you should straight away know that there's a problem. We just can't factor out y because there's, okay. So we're probably going to have to use a quadratic formula because you can see that's a y squared and this is 2y. And yeah, this is just a basic expression. So what I'm going to do is, okay, I'm just going to say y squared over 2. I'm going to bring this y squared over here. Minus 2y plus sine inverse of x over root 2 minus pi on 4 should equal to 0. Is that right? Yes. Now, okay, have a look at this. Just rearrange it to make an equation here. So have a look at this. Imagine like this over here is half is your b value. So your a value is just half. Your b value is -2. And your c value, remember this, we're using the quadratic formula here to, find y. And your, c value is just, this big expression. So sine inverse of, x over root 2 minus pi on 4, pretty much. This is your c value. So let's use it. So it's going to be -b, which is just 2. So -b plus or negative b squared. So b squared is just 4 minus 4a, which is half your value of c, which is this big thing here. So sine inverse of x over root 2 minus pi on 4. All over 2a, which is just 1, actually. 2 times a half is just 1. So simplifying this much further, plus a negative. We're just saying 4 minus 2 sine inverse of x over root 2. Okay, so that's minus 2. What's minus 2 times negative pi on 4? It's going to be plus pi on 2, pretty much. Right? That's here. The expression is going to be -2. Yes, and so that's equal to y. So hence your y is just 2 plus or negative this expression. Now we need to be sure if that's 100% sure. We need to be perfect because there's two values we have. We have y equals, plus this value or minus, as you can see from the positive and negative. So, okay, which one would give us the right answer? We luckily have the initial condition. So we know that when x is equal to 1, y should be equal to 0. So let's say when we sub in x equals 1. So if I input x equals 1, our y value should be 0. So it'll be 2 plus negative. Okay, so 4 minus 2. If I sub in 1, it's just going to be pi on 4 plus pi on 2. And that's going to be 4 minus pi on 2 plus pi on 2. These cancel out, which is just 2 plus or negative root 2. Aha. So when having that positive, it gives you a 4. Whereas when you have that negative, it gives you 0, which we want 0 to be our condition. So yes, we want the negative 1 over here. So we want to reject the positive one, and we want to let it equal y equals 2 minus the square root of 4 minus 2 sine inverse of x over root 2 plus pi over 2. And yeah, perfect. That's your final answer. Okay, guys, I hope you enjoyed the video and learned a lot through this video. Please, guys, make sure to like and subscribe and share this with your friends. Have a good day and take care of yourself, guys.